Hello friends, welcome to my channel. Let's have a look at problem 2611, Math and Chess. In this video, we're going to explain a solution based on formal computation. So basically, we use some set operation. So here, set means the set concept in mathematics. First, let's look at the problem statement. There are two maths and n different types of cheese. Each type of cheese should be eaten by exactly one mouse. So a point of the cheese with index I is reward I if the first mouse eat it, otherwise reward 2I. So we are given a positive integer array, reward 1, and another one, reward 2. And a non-negative integer key. So we are required to return the maximum points the math can achieve if the first mouse eats exactly key types of cheese. So here are two examples. Example 2 is sort of special because here the k equals the length of the reward list. Therefore, we just return the sum of reward 1. So in the first example, so in this output is 15 in here. So the first mouse eat 3 and 4, and then the second mouse can only eat 1 and 2 now. So we get 3 4s and 1 3. So that is 12 plus 3. That is 15 in total. So with that said, let's also look at the constraint. First, the length of the two lists reward 1 and reward 2 are equal, and they are not empty and can be up to 10 to the power 5th in length. So in other words, this number 10 to the power 5th, which is decently large, determines the problem set's upper bound. And secondly, the reward or element in the two reward lists is bounded below by 1 and bounded above by 1000. So this one is not that essential in some sense. So here k is greater than or equal to 0, less than or equal to n. So when k equals 0, right, so we just need to return the sum of reward 2. And when k equals n, we just need to return the sum of rewards 1. Actually, these two cases, extreme cases, are special, but also can be absorbed by the general case. So with that said, let's look at the problem explanation or the idea. So in this video, actually, the point is to understand the formal computation. The coding, actually, basically it's a one layer. So if we like to write that way, it's very short. Here, the treatment is based on some formal computation, which is our understanding or reasoning. Here, we let n equal the length of the reward list, and we call the index set from 0 to n minus 1 the full set or the universe, that is capital U. The problem here is to determine an index set A such that the cardinality or the number of elements in A is k, and we want to maximize the sum of the rewards 1 at the corresponding index for set A. And then we also get the sum of the reward 2 as a complement set, that is U minus A, right? We want to maximize this sum. But notice that the second item here is nothing but the sum of the full list, that is sum of reward 2 minus the sum of reward 2 at the index set A, right? So this one is a constant we can put in front. So this is fixed. And then we're going to have the sum of reward 1 at the index set A minus the sum of reward 2 at the index set. So these two terms here is nothing but the sum of the difference of the two reward lists at index A, right? So in order to make the full sum here maximized, so because the first one is fixed, we just need to maximize the sum of difference at index set A. So this can be easily done, right? So we can sort different sets and then pick the key largest one, right? Notice that k can be 0 and can be n, but this can be absorbed by the general case or the general idea. So with that said, let's look at the coding. The coding actually is very short. So here, in order to make some easy typing, so I'm going to change this to be R1 and this to be R2, right? Just for convenience. First, I'm going to compute the difference set. Let's do R1 minus R2 for R1, R2 in zip R1, R2, right? So this is a very simple list comprehension. And then we can sort this difference set. So here I'm going to sort with a reverse. Sort in the reverse. So this way I can pick the k largest element. Notice that here k can be 0 and can be n. If we do this, it's always fun, because if k equals 0, so this is nothing, right? And if k equals n, it will be the full sum. So here what we are going to return is nothing but sum of R2 plus the sum of difference of this key element. So if so we have an empty one, so we can make a 0, right? So this is the full solution code for this specific problem. So now let's first do a check. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, basically that's about it for this problem. So this problem is marked medium by leetcode. However, if we understand the forming computations related to set, this can be very routine in writing the solution. So with that said, I guess that's about it for this video. Thank you.